Hello and welcome everyone. Welcome to my YouTube channel and welcome to this course of Cisco ASA Zero to Hero. And this is the 7th video of this series. And in this video, we will be talking about dynamic routings. And basically, the Cisco ASA supports all the dynamic routings almost, like it's supposed the RIP. It supports Eigrp. It supports Ospf. It supports BGP. But as an example, we will be doing RIP and Ospf, both of them. RIP version 2 basically, and Ospf, and also we will be doing the authentication part of it. Okay, so yeah, that is the whole agenda of this video. Okay, so let me just clear this drawing. And let's see. Let's start with the. Routing information protocol, right? RIP version 2. Okay, what we'll be doing is the configuration commands and the authentication. So basically, just let me tell you what we'll be doing is we will be running a RIP on this and RIP over here and RIP over here, and over here, and then we'll be checking connectivity from here to here, here to here, here to here, here to here, like that. Okay, and then you will also see that you have all the routing updates here on R1. So that is how it is, and how you enable routing on these Cisco ASA is quite similar to the routers. There are, a little bit of changes. I'll be telling you. There is changes with respect to the authentication. While as configuring the RIP, as you do in your routers, how you do it is router RIP, right? Likewise, you will be doing the same here on the ASA, same command. This is how you enable the routing protocol here. Okay, then by default it does auto summary, or you have to specify the version. You can specify the version 2, and also you can say no auto summary, because by default it does the auto summary, which you don't want, right? So that is how it is, no auto summary, and that is how you do it on the routers as well, right? Okay, and network command is used to enable a routing protocol on an interface. As you know, in routers, how do you enable? For example, this router, I have to enable routing protocol here and all these interfaces. So I'll specify network, and then we'll specify the. So here on the in the RIP, you cannot specify the classless. So you have to specify 192.1.20.0/24, or you can say 255.255.255, or not required, because this is /24 and class full. And for the 10 subnet, you have to do as network 10.0.0.0. There is no option. And then for 199, this is your class C. So you have network 199.110 like this, right? And then for 200, likewise. So that is how you do here. But what about this ASA? So again, you cannot have classless subnet. So for example, you cannot have a 10 subnet here and also a 10 subnet here, and you cannot run RIP here and not here. You can do it by specifying the passive interface command. That is something different, but by the network command you have to always go for the class full subnet there. Okay, fine. So let's do this, and after that we will go for the authentication. So by default, let me just clear this. Okay, and you have the RIP, right? It supports version 2. It supports your both clear text as well as MD5 authentication. So clear text will have the password sent in the updates every 30 seconds that the RIP speaker sends. Okay, it will have the password which will be in clear text. So anybody sniffing packets on this link or on this link, they can see the password that is being set up on the devices. MD5, you will have it hashed so that you will not be able to see the password if you sniff the packet. And authentication is actually enabled on per interface basis. So you can do it globally, but again, you have to put the interface, a single command on the interface. We'll see that. Okay, so that is the whole idea of this RIP lab, and then I'll discuss the OSPF after this RIP is set up, and then we'll just remove the configs and do OSPF. Okay, so let's begin. So first of all, what I need to do is I need to go to the routers. Okay, I need to go to the routers, and let me go to the router. Wait a second. I have the So what I'll do is on R1, okay, this LAN side. So I'll go see when I go to R1 config T and I say router RIP, then I have to say the version. This is 2 that I'm running by default. Version 1 is running, and then I have to say no auto summary. Okay. Next is the network command. So here I have all the interface on 10, so I can do this and that's it. If you exit and do show IP protocols, if you do, you will see that I have this RIP running on all the interfaces that begins with 10, right? Because Ospf is sorry, not Ospf. This is RIP, right? So while specifying the network command, it doesn't take the class less subnet. So you can do this. But if you do the same thing, so if I say you should know this, but just to know router RIP, if I say, and then the router process is gone. Now let's again do the router RIP command and say version 2. Okay, and say no auto summary. Yes, and then if I specify 10 dot say just 11 10.11.11.0 and what, you cannot do the subnet mask here, right? Not allowed. Subnet mask is not allowed there, right? So you can see no option is there. If I hit enter here and if I go again to the IP protocols, and you can see again it has taken it as the classful 10.0.0.0 subnet. So that is the limitation of your RIP. Now let's do the same on all other routers. I have R2. I want the loopbacks also running this show. So I'll just do IP interface brief and I'll see what. Okay, so I'll do the config T. Sorry, config T, and then I'll do router RIP and no auto version 2, and then the network command. Network, I need 192.120.0. Then I need another one is 10.0.0.0, and I need the 199.1.1.0. Yeah, and I need the network 200.1.1.0. Okay, so that is done. If I check show IP, do show IP protocols, I'll be able to see what all interfaces are part of the RIP routing process. Okay, so you can see the 3 loopbacks and 1 gigabit 00. Next is the R3 show IP interface brief and config T. Only I have 2 interfaces, router RIP version 2 and no auto summary, and then the network. I'll say 0 and then I'll say network 192.168.3.3. Yeah, so that's R3 and R4 then again. Config and do show IP protocols, and do show IP interface brief, and then I'll say router RIP version 2, no auto summary, and then I need the network. I need 10. I need network 192.168.4.0. So that is done. Now I will go to the ASA now. I need on the 192.4.3.192.120 and the 10.11. Okay, so let's go to the router config T. First of all, I need to check if I can ping the next, routers 4.4, yeah, and I want to ping 10.11.11.1 R1. Likewise, I can ping 192.120.2 R2, and I have 192.168.3.3 R3. Fine. Now I'll specify router RIP same like we do in the routers, and then you have the version that you have to specify, version 2, and you do the no auto summary command. Yeah, and then the network command. So you have how many networks here? You have the 10. See, no, mask option gone, and then you have the network 192.120.0. You have the network 192.168.3.0, and then you have the 4.0 network. And so now just let me name this as ASA. Okay, now if I check show IP route, okay, show route only on the ASA, got it. So I should see all the rips out. Okay, I can also do rip like this. So now I should be able to ping all the next hops. Because I did no auto summary, so that's why I'm getting the subnets. Okay, or else if I had not done no auto summary, then I would get all the 10s from R1, from R4, right? Then the AC would be confused from where to send the routes. Okay, so that's said and done. Let's configure the authentication. So we'll configure authentication between R1 and ASA, and likewise you would know how to configure on other interfaces. Just for the lab purpose, I will do between the R1 and the ASA, and you will know how to do it on the other. So how do you specify on the routers? On the routers, it is different from the Ospf. So you do the keychain first. You create a keychain first of all, any name, say key, okay, and then you specify the key ID. Okay, any number, fine, 2, and then you say the actual key string, that is your password. So let's say Cisco 123, simple password. Then now you need to apply this keychain on the interface that you want to run authentication with. Authentication on that side of the device. Okay, before sending the RIP updates. So for our lab, we have gig 00, where I want to apply this keychain. So I'll go to that interface G00. Then I will say IP authentication. Sorry, but you will specify the protocol. Then you specify the keychain. What was the name of the keychain? Key. That's it. Then you specify the mode. IP RIP authentication. Is it clear text or what? MD5. So you have two options. You can do clear text, you can do MD5. Okay, so let's do MD5 here. By default, if you don't specify MD5, it will be clear text like this. If you do, it doesn't take, okay, text, and then yeah. So you have to specify this. And if you do MD5, so it takes, okay, let's do clear text, and then I'll sniff the packet, sorry, so that you can see the password being sent in the updates. Okay, and that is done. Now the rip updates will be gone for 10 1 1 10 10 and 10 20. See, 10, these will be gone. As you can see here, the timings would go up for these 10 10 10 20. You can see it's 117. After some time this will be cleared from the route. This will be increasing. Others will be resetted every 30 seconds. As you can see, the second route is on 23 seconds, 25 seconds. You see, it's again because it received another update for 10.22, but for these routes there is no update because that authentication has failed. So on the SA, how you do the authentication is a bit different because you don't specify a keychain and the key ID and the key key string outside. Okay, you just go to the interface and just specify that in the command. So for me, I'm running this on gig 00 on the firewall as well. So I need to go to that interface gig 00, not interface inside. Okay, here you go to the gigabit 00 and then you say IP command is not there, so you specify IP authentication and the key, and then the key should match obviously 1 2 3, and then you specify the key ID. I'm not quite sure they should match or not. Let's see if we keep it as different. Okay, I think it should match. Just let's try mode, and then you specify the mode. So on the other side I kept text, so here also I have to keep text. Let's see, does this side take the command like this? No, it doesn't, right? So yeah, so text. Now let's see if we receive the route from 10 to 2. Oh yeah, you can see. So that is very nice thing. So the key ID doesn't need to match. Okay, let's check the sniffer, capture the gig 00 here and see the text. See the password that is sent in clear text. Okay, so just a lab here. Okay, let's wait for this version 2. So yeah, I will get the response here. Let's check if we have any. So all the metrics are sent. Authentication, you can see simple password and you can see the password. Simple, right? So that is how you do the RIP. Now let's quickly go and remove all the configurations from here. So on the firewall, I'll say clear configure router, not route. Okay, route will remove. Then you can say the RIP only if you want to do, but I'm not running any other route, so I'll just say router. That's it. So if you see now, anything, okay, I can say router. So like that, I can see the routing configs that I have done. So there is nothing there. On the routers, I have to say no router RIP. That will do the take off the router RIP configurations. Okay, and on R3 also, let's say no router RIP, and on R4 also I'll say no router RIP. Go to the config mode, no router RIP. That should do. Okay, so now the idea is to run Ospf between the ASA here and then the routers, all 4 of them, and then we'll see the connectivity. Okay, that is the thing. And as you know that the Ospf actually has the concept of areas, but in this case we will go in a single area. We'll not be doing multi-area configs. So this all will be in area 0 or any area. If your design is having only one area, it is not necessary you do it as area 0. You can have area 100, whatever. Okay, so let's do a quick recap. So for running a router, OSPF on routers, you specify again with the router command, right? Router and then OSPF and then the process ID that need not to be same on all the routers. Okay, because it's locally significant and need not match the remote router. OSPF router are grouped into a logical entity known as area. Yeah, in our example, we are going to use a single area 0. Okay, so OSPF routers are actually identified by IP addresses that you call as router ID. Again, the router ID concept is that if you have, priority will be given for the static entry that you do in the router config command. You can say router ID and it is denoted in a 32-bit format. That is the first priority. Second is the loopback. Highest loopback IP address will be taken, and third is the highest interface IP address will be taken. Okay, not the interface number, the IP address that is highest configured on any of the interfaces that will be taken as a router ID. But we will be configuring the router IDs. This will be 4.4.4.4 like that. This will be 2.2.2.2 so that we can verify, right, which updates are being received from which router. And this will be our 10.10.10.10 router ID. Okay, so that is the idea here, and also we'll be doing the authentication here. But once you say router OSPF, then you can specify the router ID. We'll be doing that, and then the router ID in a 32-bit format. Then you again do the network statement on the routers. Just a bit different is that, for example, if I go on this router, I will say 192.1.20.0 if I want to do on the whole network, or if just that I host IP, then .2, and then you go for the wildcard mask if it's /24 like this. But in case of ASA, there is no concept of wildcard mask, so the network command would be just with the subnet mask 120.0. It will be like this, 255.0. Okay, so that is the catch there, and then obviously the area of it. Okay, so I forgot, I've not specified the area here, but area has to be there on the router as well as on the AC. Okay, so that's that, and then we'll do the authentication. OSPF again, supports both the MD5 as well as the clear text, but OSPF has neighborships, and if the authentication is not matched, the neighborship will go down, or even the modes, if it doesn't match, neighborship will go down. And the authentication is done on the interface of a router as well as on the AC. But I will show you that you can specify enable the authentication globally, but then you have to go onto the interfaces one by one to enable the authentication there. Okay, that is a option there. So first of all, let's go and configure the OSPF neighborship, and then we will do the authentication part. Okay, so let's go on the routers first. On R1, let's start with R1. I'll say router OSPF process ID 1. Then I will say router ID 1.1.1.1. Then I have to specify the network. So I want to run this on the the interface that is going to the AC, and then I want to run this on the 10. I think I have 10 there or 20 there. I have 1, 10, 1, 1 and 10, 10, 10, 10, 20. So I want to run that on all the interfaces there. So you can also say like this, like a host, only that interface will be running with Ospf. And then you have the 20.0 and then dot 255. And I think that is it, right? I have 10, 11, 10, 10, 10, 20. I didn't specify 10, 10, right? So let's do 10, 10, 10. Okay, that is done. So our router is up with Ospf. If you go and do the protocols command just to check the process. Okay, I said run, so I can say only this. So you can see that these interfaces are part of area 0. Okay, and this is Ospf 1. You can also say the command show IP Ospf to check the other details like the router ID. Again, here you can check the process and also the other configs like the LSAs you have not received, so these are there, but you can also have the intervals here and what, and you can check the, what I want to see is supports only single task. Okay, LSAs. Okay, these are advanced Ospf concepts. Oh, I want to see this actually. Number of interfaces that are in this area is 4. But if you want to see those interfaces, you have to do show IP protocols. Yeah, you can see those 4 areas. And also you can do show IP or Ospf interfaces in case you want to check the interface itself. You can have the brief command to have a slightly less information over there, like that. Process ID 1 is running on those. It's part of area 0. These are the addresses with the mask and the cost and all the other configurations. Okay, let's do this on ASA. So here also you do the same router command, right? Router Ospf and 1, 2, whatever 1. Okay, but the idea is you should have process 1 on all the only one process running. You can have multiple processes, but then you have to do advertise drugs, you have to do redistribution. That is a different topic. So here you specify the router ID. Yeah, this is actually the ASA, so this will be 10. Then you have the network command. So in my case, I have the 10, 11, 11, 0, and then you specify the subnet mask, not the wildcard mask, with the area 0. And let's see show Ospf neighbors. You can see directly. Yeah. So if you go and you can see that you have a neighbor on the inside interface. And if you check the show route with Ospf only, you'll see 10, 1, 10, 10, and 10, 20. So you can go and now ping the ASA can now reach the loopbacks on R1. Yeah. So that is how you do the Ospf on the ASA. Now let's go to R2 and do the Ospf here again. Enable router, okay, config, and then you have the router Ospf 1. Yeah, and then you do the router ID. This is R2, so 222, and then I have the network 192.120.0, and then the wildcard mask, and then you specify the area. Done. And also I have the 10. I think what is the 1022? Yeah. Then I have the 10.2.2.0 here. I want to run that 255 area 0, and also the 200. And then you have the all zeros. I'll match that, and also I'll match 199.1.1.1. and all zeros, area 0. Yeah, and if I see OSPF neighbors, I should have neighborship with my route. Okay, I've not actually configured the ASA on that interface, right? But here you can see all these are there, and if I see IP OSPF interface brief, I should see all the 4 interface, 3 loopbacks and 1 physical interface. Okay, I'll go to ASA and I will say again, I have the config T. I am running router OSPF already there with the process ID 1. I just have to specify the network, that is 192.120.10, and I can do a specific interface like this, or even you can go to the interface and do the interface configuration. Okay, so that's it. And now let's go to R2 and see the, you can see that the neighbor is up. If I say show IP OSPF neighbors, I should see 10 10 10. That is my ASA have neighborship with this. Now if I check the route here, I should have 10 11 10 10 and 10 20 here. As you can see, I have all those routes here. Show IP route and then OSPF. If I do only, you can see that, but I will not be able to ping these interfaces because again on the ASA, this is high to low. I need a ACL to allow that. Okay, and also from inside, if I check show IP route OSPF, I should see 200, 199, all those here, but again, I'll not be able to reach that loopback. Again, the reverse traffic is blocked by ASA because it doesn't inspect ICMP. But there is a command on ASA which many people don't know. As I said in the beginning videos, that we can inspect ICMP, right? Going to the policy and specifying. Just let me show run. I don't need the do command here on the ASA. All the time you do this mistake of doing do. Okay, anyways, so what I was talking about was the inspection of ICMP. Yeah, you can see I don't have inspect ICMP here. I can go to this policy map, class, and then inspection default, and then I can say inspect ICMP, right? That is one thing. And there's another one. I think this is fix up ICMP command. Yeah. So when you do this, fix up protocol, and then you can say any of this, and it will be inspected. So here you also have ICMP, and if you do ICMP, now you will see in the run that the ICMP is inspected there. If you go here now, now you can see that ICMP has been added here. So this is a kind of shortcut. Okay, so now if you go to your inside, okay, that ping that was not working earlier is going to work now. Okay, but from R2 again, it will not work. Again, the same logic of low security to high security. Okay, so that is again an information there. So now let's do, I'll not be doing R3 and R4. Okay, you can do it by yourself. Now let's do the authentication part. So on routers, you don't have the concept of keychain and all on ASA. You go to the interface, on the routers as well. You go to the interface and directly do the authentication mode and the key. Okay, so let's start with R2. Okay, and you will see once I configure on R2, and the neighborship is going to go down. So on R2, my interface that is going to the ASA is gig 00. So I'll go config T interface gigabit 0 bar 0, and then I will say IP OSPF and then authentication. You have the option here, right? Message digest means MD5, which is hashed again. You can do that. Okay, but if you just press enter here, it will be clear text by default. Okay, so I'll do message digest here. Done. After that, nothing there. Okay, then you have to specify the key. Again, IP OSPF, then you have the authentication, then hyphen key. Then you have here you specify the key. As you can see, after I do this, the neighborship should go down, because you have the flag of authentication set in the OSPF hellos, and the neighborship should go down. Okay, if I see show IP OSPF neighbors, okay, let's wait. 3, 2, 1, 0, and gone. Yeah, so that is what I was talking about. And also, if I exit here and if I see the route, obviously that will be gone. Yeah, no OSPF routes. Okay, now you have to do the same on the ASA side, and on ASA also you do the same thing apart from the IP keyword. So here also you go to the router, not the router, sorry, the interface, that is gig01 towards R2. So you go to the interface, gigabit 0/1, and instead of IP OSPF, we do OSPF authentication message digest. That's it. And then you again do OSPF authentication key. Okay, then the key you specify. Authentication, yeah, authentication hyphen key, and then Cisco 1, 2, 3. That's it. This should actually match. Yeah, the key should match. That is very important, right? Once you do this, you'll go to R2 and you can see that the routes are back. Yeah, and from R1, if you try to ping the same subnet, it is going to be reachable. Okay, so that is how you do the authentication, and hope you understood the concepts. I mean, you can go on and do the labs as I'm doing side by side, so that you get more clarity on this. Yeah, and also, I mean, if you have any doubts, kindly reach me, comment, and you can reach me. And please don't forget to like, share, and subscribe to my channel. And I mean, it will be great if you provide your suggestions. And for now, it's bye-bye. See you in my next video.